So, water jet cutting has many advantages over traditional methods of cutting. And briefly, what water jet cutting is you send a stream of water that's really fast moving to cut stuff. And sometimes in the stream, you add abrasive materials like sand or something. Can be very clean because it's water plus some abrasive materials had, which can be very, very clean itself. It can also, you can ignore wear and tear on a lot of things because water does not get wear and tear. It can add something to cool off the material. It can reduce sparks. If it's metal, sometimes it can spark. Kickbacks and stuff like that. But there's a lot of cons too, because water can splash around and also abrasive material. The abrasive material acts in water that can to some extent wear down. So it might not always be the most precise method because of splashing stuff. So here's some ideas I have to maybe improve the technology. One of my first idea is to have a sort of laser add-on. And this can do a couple different things. One is, if you have a very powerful, finely focused laser at that hits where the water jet hits the material, or just a little bit above it or below it, the water jet can be made to pulse and kind of heat up really quickly and explode. This explosion, the super brief explosion, can give it more power to burst through it, because you can actually direct the explosive energy mostly downwards or at an angle, giving it an extra burst of energy. You can also use it to heat up the material or the water to make it able to cut better. And this means the actual water jet device could be made less powerful with a stream of water, or make it more thin and finely focused, so you can cut more precise angles, or a little bit of both. You can also use this to direct the water jet with the laser in different angles more, without moving the head around, to let for more angled cuts or precise cuts. So now, of course, whenever you have lasers, there's a lot of safety risk with the actual laser involved. Another idea is to move the head with the actual water jet back and forth in a faster way. The advantage of this would be that if you start cutting something and the water starts backsplashing, it interferes with the cutting power of the whole thing, because some of the water is backsplashing, pushing against the water that just hit it, back and forth. If you can move it a little way, quickly back and forth, like it's going back and forth, vibrating, so it goes left to right, right to left, back and forth over the same area to make a straight cut, for example, then some of the water that's passing back and forth will not hit the older water, and also more debris can clear out more easily as it goes from side to side. The problem with moving a head quickly back and forth is, even though it can be more precise, is that you have all that pressure that you have to also move in the actual head, the water fighting it, like bending a hose with a lot of pressure might be difficult. Another idea is to make the whole device in the table with all the metals or pieces actually move back and forth quickly to do the same effect. Or we can combine them to make it even faster movement, or more precise. Another idea kind of along these lines is to add an ultrasonic vibrations. And these ultrasonic vibrations could do a couple things. One, by making the pulse higher pressure and lower pressure very quickly, we can make sure the water that's backscattering and taking out debris doesn't interfere as much with older water. In fact, they can build up some harmonics to increase the power potential. Also, ultrasonic things can have something called cavitation, where it makes little bubbles because of all the pressure changes that collapses and releases a lot of energy to cut something even more with more power and focus, so you can make even a smaller stream that, again, that's just as powerful, will make for more precise cuts. And a small stream also might have to clear away less debris and have less of the back one. Ultrasonic things can also heat up a surface more and also can be used for cleaning, so you could use it for that part too, especially rust. And the ultrasonic things also better removing stuff that doesn't fit together as well. So rust doesn't fit as well on oxides on the actual metal because they have different crystal structures, for example. So by that and other dust and dirt and impurities you could potentially remove. Another thing is to kind of along these lines is to have the actual pump that's pumping it before it's really pressurized, but it's pumping the raw water, have a vibration mode that's not ultrasonic. And then when it gets pressurized, you shift the frequency. And by that shift in frequency, as you pressurize it and make it move faster, the frequency actually becomes small and compressed. And having a small compressed frequency then can shift something from non-ultrasonic to ultrasonic, and or it can even make it have pulses that are very, very quick, that it just hits the thing and back scatters. The next one hits the thing and scatters, and so on, interfering it, and it has a middle zone with almost no water in between. Another idea is to add a vortex to this whole thing, where the water is spinning, and you can do before you highly pressurize it, or after it using ultrasonic vibrations that are perpendicular to each other. So one's coming from left to right, one's coming from up and down, for example. And the spinning can help give rotational energy that can kind of drill through a material, but also reduce scattering in unintended ways that are bad. Another idea is to make the abrasive for all this stuff paintable. So you just paint on it, and maybe the device itself paints on abrasive, and that way you can have a more powerful water jet without including the abrasive firsthand in it. And that means that the water jet itself doesn't have to handle those abrasive materials and maybe can last longer. It might also reduce error and make stuff more precise. Having local heating and cooling could also maybe hugely benefit this whole thing, because sometimes material, depending on the temperature, can cut more or less easily, but also shrinkage, if it rapidly cools or expands, can cut the material and make it crack or break apart locally. So you can imagine that if you have a material hot and you hit it with cold water, it suddenly shrinks and pulls apart. Or you could hit it with hot water that locally heats it up and cuts it better. Now, this might not be best for certain materials that don't do this very much or much stronger. Hitting it at angles might reduce backsplashing straight up to it, which might lead for better cuts too. Another one might be to first somehow make channels in this whole device that are not as deep, but also redirect the water that's splashing out more, so it becomes more of a precise cut and a better cut. And figuring out how to make those channels. So another idea is to figure out better cut directions using software and AI to figure out this whole thing for you, so you do not have to be as intelligent when figuring out stuff. A huge bonus right there. And also, maybe if we can flip over the material, for example, or something like that, flip over the material, we can have it also cut from different directions and stuff like that. So my meaning doesn't need to make as long or deep as cut for more preciseness. Another thing is, let's replace and we always kind of do this, let's replace the water with instead pressurized CO2 or nitrogen that we then shoot through the whole thing, and then we can accelerate the plasma to incredible high speeds so they can really hit stuff. And then when they hit the material, they're almost like a solid, but then they vaporize. So the backsplash is not as much of a problem. But that's a lot more of a fancy setup. Also, something I forgot to mention here is that we could use it apologize, it keeps doing the wrong thing. So we could use air to also surround it, or even plasma surround the water and keep it in a more focused way. The last thing is maybe we can use sensors that look at real time, include thermal sensors to look at the heating vibrations to make slight corrections and adjustments, and also take away human beings more and more and more. Well, thank you very much for listening. Please like and subscribe. It will help the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours. It's really help, I think, to do it. So if any of these for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much.